Good afternoon students, I am Kavita Monga, lecturer of physics from Government Polytechnic College, Khuni Majra. Today we will study about conductors, superconductors and Kirchhoff's law. To start with, first of all we will discuss material classification. So materials, they can be classified as conductors, insulators and semiconductors. So जो materials हैं जितने भी, we can categorize them in three types. They can be conductors, they can be insulators or they can be semiconductors. So we can differentiate between insulators, semiconductor and conductors on the basis of energy bands or energy level diagram. For insulators, the energy gap between valence band and conduction band is high. So large energy gap between valence and conduction band. So it is difficult for electrons to jump this gap, and so they are bad conductors of electricity. So insulators, they are bad conductor of electricity because this energy gap is very high in case of insulators. In semiconductors, this energy gap, this is of the order of 1 electron volt, but still they are not very good conductors. So the difference of energy between valence band and conduction band is of order of 1 electron volt in semiconductors. So semiconductors, in pure state, they are not good conductors of heat and electricity. In conductors, this energy gap, there is no energy gap. The conduction band overlaps the valence band, and in conductors, electrons for valence band they can easily jump into the conduction band. So free electrons, a large number of free electrons are available. So conductors, they are good conductors of heat and electricity. So this is how we can distinguish between conductors, insulators and semiconductors. Conductors, good conductors of electricity. Insulators, bad conductors of electricity, because this energy gap is very high and it is very difficult for electrons to jump from valence band to conduction band. And semiconductor, they lie in between conductors and insulators. So now just see, let's define what are insulators. This separation of the valence and conduction bands determines the electrical property of the material. So in the previous slide we have seen the bands, valence band and conduction band. So in insulators, what happens? Insulators has a large energy gap. Electrons can't jump from valence to conduction bands, so no current flows. So insulators are bad conductors, no current flow. In conductors, or you can say metals are good conductors. Conductors have a very small or non-existent energy gap. So conductors में valence और जो conduction band है overlap कर जाते हैं. So energy gap is very small or there is no energy gap. So electrons easily jump to conduction bands due to thermal excitation. Current flows easily. So conductors, they are good conductors of electricity. Then come semiconductors. Semiconductors, they have a moderate energy gap. Only a few electrons can jump to the conduction band, leaving holes behind. Only a little current can flow. So insulators में no current flows. Conductors, current flow easily. Semiconductor, only a little current flow. This is when they are in pure state. When the semiconductors, they are in pure state, only a little current can flow. Now let's define what is resistance. Resistance is the property of a material by virtue of which it opposes the flow of electric current through it. So that property which opposes the flow of electric current. Since current is the flow of electrons or charges, hence the resistance is an opposition to the flow of electrons or charges. This opposition occurs because of the presence of a large number of atoms and molecules in the substance through which current flows. So substance में, material में, there are large number of atoms and molecules और electrons को they have to flow through them, cross करना पड़ता है. So they oppose the motion of electron. So the opposition occurs because of a large number of atoms and molecules. The SI unit of resistance is ohm. Resistance का unit ohm होते हैं और it's denoted by the symbol this omega. So now we can define what is 1 ohm. A wire is said to have a resistance of 1 ohm if it develops 0.24 calories of heat when 1 ampere current flow through this wire for 1 second. So this is how we can define resistance of 1 ohm, that अगर उसमें से 1 ampere current flow करे for 1 second, then the heat developed will be 0.24 calories. Then the resistance of the wire is 1 ohm. Now next, what is resistivity? Actually we have to define what is conductance and conductivity. So before going to conductance and conductivity, we must know what is resistance and resistivity. So now what is resistivity? When electric charge flows through a circuit, it encounters electrical resistance. So the resistance of a metal conductor is a property which depends on its dimensions, material and temperature. So resistance डायमेंशंस पे डिपेंड करती है, मतलब जो आपका मटेरियल है, वायर है, उसकी लेंथ क्या है, एरिया ऑफ क्रॉस सेक्शन क्या है. इट ऑल्सो डिपेंड अपॉन मटेरियल कि वायर किस मटेरियल की बनी हुई है, कॉपर है, एल्यूमिनियम है या कोई और मेटल है. एंड इट ऑल्सो डिपेंड्स अपॉन द टेम्परेचर. So at a specific temperature, the resistance R of a metal wire of a length L and cross sectional area A is given by R is equal to rho L upon A. So R is resistance, L is length and A is area of cross section, where this rho is a constant of proportionality and is called the resistivity. So resistivity, this rho, this is a constant, its value is different for different materials. So that means the property जो भी हमने ये बात की, the resistance depend upon the material. So different material के लिए the value of rho will be different. So what is rho now? Rho is a constant of proportionality and we we call it as resistivity, or sometimes we also call it as specific resistance. So the unit of resistance is ohm. R के unit ohm होते हैं, rho के unit will be ohm into meter. इस एक्सप्रेशन में rho will be R A upon L, और अगर हम units डाल दें R के L और A के, then rho के units they come out to be ohm into meter. So resistivity, its units are ohm into meter. So from Ohm's law, so we know that R is V upon I, or V is equal to IR. So R, resistance R is given as V upon I. V is measured in volts, current is measured in amperes. So this volt upon ampere, this is equal to ohms. R depends upon specimen shape, but we need a term that is independent of geometry. So this is rho. In the previous slide हमने देखा था कि this rho R is also given as rho L upon A. So from that expression, rho is R A upon L. So this is rho is resistivity, R is resistance, A is area and L is length. So A is area of cross section, L is length of the conductor. So rho resistivity, it is measured in ohm into meter. Now next we are going to define what is conductance. Till now we have defined what is resistance and what is resistivity. Now reciprocal of resistance is called conductance and its symbol is G. Reciprocal of resistance R is called conductance and its symbol is G. So G is equal to, this is given as mathematically, G is reciprocal of R. So G is equal to 1 upon R. So its unit will be, that means 1 upon ohm, and we call this as mahu. So conductance के unit mahu होते हैं, conductance का symbol G है and conductance is reciprocal of resistance. So G is given as 1 upon R. So we can say this is the easiness with which the current or charge can flow. Resistance हम कहते हैं, this is the opposition to the flow of current. This is the opposition to the flow of current is resistance, and conductance is the easiness with which the current or charge can flow. So reciprocal of resistance is conductance and reciprocal of resistivity is called conductivity. So reciprocal of resistivity is called conductivity. So that means this sigma, this stand for conductivity, and rho is 1 upon sigma, or you can say sigma is 1 upon rho. So what is conductivity? Conductivity is reciprocal of resistivity. So rho resistivity is Ra upon L, so this is 1 upon sigma, where sigma stands for conductivity. So conductivity is largest for metals and smallest for insulators. Metals गुड कंडक्टर्स के लिए कंडक्टिविटी ज़्यादा होगी और इंसुलेटर के लिए कंडक्टिविटी कम होगी. रेजिस्टिविटी इज स्मॉलेस्ट फॉर मेटल्स एंड लार्जेस्ट फॉर इंसुलेटर्स. सो मेटल्स के लिए रेजिस्टिविटी कम है और इंसुलेटर के लिए रेजिस्टिविटी ज़्यादा है. सो कंडक्टिविटी इज रेसिप्रोकल ऑफ रेजिस्टिविटी. So again, Ohm's law, V is equal to IR, resistance R, this is rho L upon A, where rho is resistivity and sigma is conductivity. So conductivity sigma is 1 upon rho. Conductivity is reciprocal of resistivity, this is given as 1 upon rho. Now next start with another topic. Next topic is what are superconductors. So till now we have defined what are conductors, what is resistivity, what is resistance, and what is conductance, and what is conductivity. So these 4 terms we have discussed so far. Now next let's start with what are superconductors. So following the path of least resistance, that means we are moving toward low resistance. How superconductors, they have almost zero resistance. So now what is superconductivity? For some materials, the resistivity vanishes at some low temperature. टेम्परेचर कम करने से कोई मटेरियल्स, सम मटेरियल्स, उनकी resistivity vanishes, मतलब resistance becomes zero. So they become superconducting. So superconductivity is the ability of certain materials to conduct electrical current with no resistance. So resistance is zero. Thus superconductors can carry large amounts of current with little or no loss of energy. So just see in this graph, for non superconductive metal, अगर कोई ordinary से metal है, so temperature is decreasing in this direction. From 0 Kelvin we are moving toward high temperature, so that means temperature is decreasing towards this side. So as the temperature is decreasing, the resistance is also decreasing. But for metals it is not zero, the resistance is not zero for metals. But in superconductors what happens, they are special particular materials that at some particular temperature, which is called TC, critical temperature, at critical temperature the resistance becomes zero, so they become superconductors. So superconductors can carry large amount of current with little or no loss of energy. There are 2 types of superconductors, type 1 superconductors and type 2 superconductors. Type 1 superconductors, they are pure metals, have low critical field, and type 2 superconductors, they are primarily of alloys or intermetallic compounds. Sorry. Now related to superconductivity is very important effect called Meissner effect. Now let's see what is this Meissner effect. When you place a superconductor in a magnetic field, when you place a superconductor को किसी material को magnetic field में रखोगे, the field is expelled below, the field is expelled below TC. मतलब temperature अगर critical temperature से कम हो जाए तो जो field है, this will be repelled, this will be expelled. So just see here in this diagram, T is greater than TC. अभी जो temperature है वो critical temperature से ज़्यादा है, तो the field, this is in the form of parallel lines. So some superconducting material is there, this B is represent magnetic field. So this is straight line when the temperature T is greater than critical temperature. But when the temperature decreases, कम हो गया temperature, then what happens, this magnetic field is repelled, it is expelled. So current I appear to cancel B, the current I appear to cancel B. So what is B? B is field. So I cross B on the superconductor produces repulsion. So this on the conductor means the superconductor, it will become repulsive, it will start repelling. So this is it is shown here, a superconductor is there and a magnet is there. So in the next slide we will see how this happens. A a superconductor displaying the Meissner effect. So the magnet is repelled. Magnet is repelled. So superconductors have electronic and magnetic properties. That is, they have a negative susceptibility and acquire a polarization opposite to an applied magnetic field. This is the reason that superconducting materials and magnets repel one another. Superconducting materials and magnets, they repel one another. If the temperature increases, the sample will lose its superconductivity and the magnet cannot float on the superconductor. So that means if temperature is below critical temperature, the magnet will float over superconductor. So this is Meissner effect. So just see in this figure, the heavy person, it is floating. So there is gap between superconductor and magnet. So how this gap is produced? This is due to repulsion. Superconductors, they repel magnet below critical temperature. So this is Meissner effect. Now next, what are applications of superconductivity? There are a lot of applications of superconductivity. Let's start with magnetic levitation. So magnetic levitation, the track or walls, track of train, ये रेलवे ट्रेन का एग्जाम्पल है, मैग्नेटिक ट्रेन का. The track, railway tracks are walls with a continuous series of vertical coils of wire mounted inside. The wire in this coil is not a superconductor. As the train passes each coil, the motion of the superconducting magnet on the train induces a current in these coils, making them electromagnets. So now what happens? The electromagnets on the train and outside produce forces that levitate the train. Levitate means rise, lift the train and keep it centered above the track. So in addition, a wave of electric current sweeps down these outside coils and propels the train forward, and the train start moving. So this is an application of superconductors in magnetic levitation. So superconducting magnetic levitation, this is how it happens. Next application of superconductors is medical application. So MRI, magnetic resonance imaging, scans produce detailed images of soft tissue. So सबने MRI का नाम सुना हुआ है. MRI stand for magnetic resonance imaging. So it scans, जो ये scanning होती है, it produce detailed images of soft tissue. So this machine is shown in this figure, this image. This is a scanning machine. एंड ये जो फिगर दिखा रही है, ये आपको एक MRI दिखा रही है. सो इमेज ऑफ सॉफ्ट टिश्यूज. द सुपरकंडक्टिंग मैग्नेट कॉइल्स प्रोड्यूस अ लार्ज एंड यूनिफॉर्म मैग्नेटिक फील्ड इनसाइड द पेशेंट्स बॉडी. पेशेंट को इसके ऊपर लिटा दिया जाता है एंड इट इज़ मूव्ड इनसाइड दिस कैबिन, और उसमें एक यूनिफॉर्म मैग्नेटिक प्रोड्यूस फील्ड जो है, इट इज़ प्रोड्यूस्ड इनसाइड द पेशेंट्स बॉडी. नेक्स्ट एप्लीकेशन इज पावर. सो ट्रांसमिशन केबल जो है, दे कैन बी यू मेड अप ऑफ सुपर कंडक्टिंग मटेरियल. सुपर कंडक्टिंग ट्रांसमिशन केबल्स फ्रॉम अमेरिकन सुपर कंडक्टर. Sorry. The cable configuration features a conductor made from HTS wires wound around a flexible hollow core. Liquid nitrogen flows through the core, cooling the HTS wire to the zero resistance state. The conductor is surrounded by conventional dielectric insulation. The efficiency of this design reduces losses. Now next, let's start with another topic, that is Kirchhoff's law. So अभी तक हमने we have discussed resistance, resistivity, conductance, conductivity, and what are superconductors and its applications. Now another topic, we start with Kirchhoff's law. So this is the scientist. He invented spectroscopy. and he formulated rules about radiation, and he survived from 1824 to 1887. So Kirchhoff's law से पहले we have to define few terms. सबसे पहले what are nodes? A node is defined as a place where two or more components are connected. So in a circuit where two or more components, just see in this circuit, source of voltage is there, four resistances are there, RC, RD, RE and RF. So a node is defined as a place where two or more components are connected. The key thing to remember is that we connect components with wires. It does not matter how many wires are being used, it only matters how many components are connected together. So now let's see how many nodes are there in this diagram. To test our understanding of nodes, let's look at the example circuit given here. How many nodes are there in this circuit? So there are three nodes which are shown with this dark blue color. In this schematic there are three nodes. These nodes are shown in dark blue here. So just see here, these are three nodes, means the point, what are nodes? Where the components are connected. So components means here three resistances are connected, again here three resistances are connected, and here the one resistance and these two voltage sources are connected here. So there are three nodes in a circuit like this. When they do it, usually because they have considered 2 points connected by a wire to be the two nodes. So there are three nodes in this circuit. Now let's define what is a loop. Next is what is a closed loop. A closed loop can be defined in this way: start at any node and go in any direction and end up where you start. Means आपने शुरू करना है एक end से and then you have to come back to the same end. This is a closed loop. Note that this loop does not have to follow components. It can jump across open space. Most of the time we will follow components, but we will also have situation where we need to jump between nodes that have no connections. So what are loops? Closed loops. So a closed path, starting from a point, you have to cross components and then you have to come back to the same point. So this is a closed loop. So an example now, how many closed loops are there in this diagram? In this circuit diagram, to test our understanding of closed loop, let's look at the example circuit. How many closed loops are there in this circuit? So there are several closed loops that are possible here. बहुत सारे closed loop हो सकते हैं. We will show a few of them and allow you to find the others. So just see here, सबसे पहला जो loop will be, here is a loop we will call loop 1. This path is shown in red. So एक loop तो ये हो गया. Okay. Second loop, this path. अब हमने ये ऊपर वाला छोड़ दिया, we are following this path. So ये red वाला, this closed path, this can be the second loop. Now this can be the third loop. So यहाँ पे अगर आप देखोगे, there is no connection, but it is a voltage source. So we can jump from this point to this point. So here is the loop 3. The path is shown in red. Note that this path is a closed loop that jumps across the voltage labeled Vx. This is still a closed loop. So another possible loop, this is fourth loop. Again this is shown in red. Note that this path is a closed loop that jumps across the voltage labeled Vx. This is still a closed loop. The loop also crosses the current source. This loop also crosses the current source. Remember that a current source can have a voltage across it. So this is another loop. Okay. So next, now this जो ये diagram में जो दिखाया गया है, this is not a closed loop. So this is not a closed loop. The path is shown in red here is not closed. Note that this path does not end where it started. So this is very important point that the path does not end where it started. जहाँ से ये शुरू हुआ था वहाँ ये ख़त्म नहीं हुआ है. So it is not a closed loop. So I think now you understand what is a loop. So now quickly summarize. Note any point where two or more circuit elements are connected together. Wires usually have negligible resistance. Each node have one voltage. So what is a branch? A circuit element between two nodes. This is called a branch. Another important term, branch. So what is a branch? A circuit element between two nodes. दो nodes के बीच में जो circuit है, that is a branch. And lastly, loop क्या है? A collection of branches that form a closed path returning to the same node without going through any other node or branches twice. So closed path. This is a loop. So now next let's consider an example. How many nodes, branches and loops? So in this circuit diagram, find out how many nodes are there, how many branches and how many loops. So सबसे पहले we start with nodes. So in this example there are 3 nodes. So यहाँ पे join हो रहे हैं, यहाँ पे again 3 connections, again यहाँ पे 4. So there are 3 nodes in this circuit. There are 5 branches, 1, 2, 3, 4 and 5. ब्रांचेस क्या होती हैं? दो नोड्स के बीच में जो भी हमने कंपोनेंट लगाया है, ऐड किया है, दैट मेक्स अ branch. So there are 5 branches in this circuit example and there are 3 loops starting at A. So one loop will be this closed path, second will be this closed path and third will be this closed path. So there are 3 loops in this example. Now let's define what is Kirchhoff's current law. So there are 2 laws, Kirchhoff's current law and Kirchhoff's voltage law. So first we start with Kirchhoff's current law. With these definitions we are prepared to state Kirchhoff's current law. So after defining node, branch and loop, now we can define Kirchhoff's current law or Kirchhoff's first law. So it states the algebraic or signed summation of currents through a closed circuit must be equal to 0. Sorry. The algebraic summation of currents through a closed surface must equal to 0. That means in a closed path, the algebraic sum of all the currents must be 0. So the algebraic summation of currents through any closed path must be equal to 0. This definition essentially means that charge does not build up at a connection point and that charge is conserved. So very important point, the Kirchhoff's current law, इससे हमें पता लगता है कि the charge is conserved. चार्ज किसी पॉइंट पे जनरेट नहीं हो रहा, चार्ज इज फ्लोइंग, करंट इज मूविंग. सो किसी भी सर्किट में पॉइंट में अगर करंट आ रहा है तो इट विल हैव टू लीव दैट पॉइंट आल्सो. सो इनकमिंग करंट इज इक्वल टू आउटगोइंग करंट. सो दिस इज Kirchhoff's फर्स्ट लॉ और Kirchhoff's current law, that incoming current is equal to outgoing current. So it means that the charge does not build up at a connecting point or connection point and that charge is conserved. So this definition is often stated as applying to nodes. It applies to any closed surface, किसी भी closed surface पे apply होगी. For any closed surface, the charge that enters must leave somewhere else. Means जो current आ रहा है वो जाएगा, जो charge आ रहा है it has to leave. So a node is just a small closed surface. A node is the closed surface that we use most often. But we can use any closed surface and sometimes it is really necessary to use closed surface that are not nodes. So again next now we will have to see the sign of current. Current polarities means current को आप sign क्या दोगे? It will be positive or negative. हमने बोला the summation means sum of all the currents is 0. So if sum of all current is 0, that means some must be given positive sign and some has to be negative. So again the issue of the sign or polarity or direction of the current arises. When we write Kirchhoff's current law equation,